7576 are about functions, okay? We have been working with functions, so please don't let this scare you. Function is another way, it's kind of like when you are working in, if you're speaking in English and you go to Britain and they have a different dialect and a few different words, they're talking about the same stuff. They may use words just a little bit different. They don't use bathroom, they use water closet. There's different things that they use. So what we're going to show you is just another way of writing some of the stuff that we've already done. We are also going to define a function. Up to this point, we've never defined what a function is. So we're going to find that, and we're going to define what domain and range are. Every function has a domain, and every function has a range, and we're going to define that. So this is going to be a lot of just figuring out what the similarities are and what these words mean and how to look at them. Okay, so the functions we have looked at so far are linear, which is y equals mx plus b, okay? That is a function. I will just tell you, that is a function. We have used the equation y equals mx plus b. The reason we use y and x is because when we make our little chart, we look at the x and the y, and when we make our graph, we have a y-x axis and an x-axis. So that makes sense to us. It makes sense that we would say y. We would use x because that's how we do the graphing. Okay. So that's one way of looking at it. The other one that we just looked at was exponential functions, and that was y equals a times b to the x power. Again, notice we have an x and a y. Notice it's y equals, okay? The y is by itself each time, and that's so you can find, if you have the x, you can find the y very easily, okay? Again, we make a chart with x's, we come up with y's, we graph it on our x and y. A linear function will give us a straight line. A quadratic or an exponential function will either come down like this, or it will go up like this. This is increasing, this is decreasing, this is growth. This is decay. Okay. Linear functions can also come down. Okay. This is growth, but it's at a constant rate. This is decay, but it's at a constant rate. Constant. Yeah, I see. I spelled that wrong. I was looking at this going, okay, there's something missing up there. Constant. There we go. This goes up as a repeated multiplication. The other goes up as repeated addition. Okay. This growth rate is constant, but it's going up by multiplying. And so what happens is it doesn't look like a constant going for each thing. Okay, those are the two that we've actually already looked at. These are functions. Okay, so we've had familiarity with functions. We've worked with them. We have made we've made models for them. We have done a whole bunch of stuff with working with these. Okay. So what a function is. This is what a function is. A function is defined as a relationship that has only one output for each input. Okay. The output is called your range. Your input is called the domain. What we have used as our output is the letter Y, and what we have used as our input is X. Okay, so an output is when I put, if I have the equation y equals 2x plus 7, when I put a value in, like 1, I get 9. I don't get any other number, I get 9. Doesn't matter how I put 1 in there, if I put 1 into this, my output will be 9. Notice I get only one number. Okay. If I put in 5, I get 17. I don't get 22, I don't get 1,000, I don't get -5, I get 17. There's only one answer. That's what it means that I only get one output, one value, when I put a number in as the input. Okay. Same thing with down here. If we had y equals 10 times 2 to the x. I made this easy so we could do it in our heads. If I put 0 in, I get 10. I don't get anything else because remember 2 to the 0 power is 1. 1 times 10 is 10. I don't get 20. I don't get 35. I only get one number, that's 10. Okay. If I put 1 in, I get 20 as my answer. I only get the answer 20. I don't get anything else. So every time I put something in, I only get one answer. That's what a function is. When I put a number into it, the input, which is the x value, and that stays the same in function notation, okay? The x value stays the same. It stays as x in your equation. Okay. The thing that changes in function notation is our output. So instead of writing it like this, a function in function notation, instead of writing y, they replace y with f of x, g of x, or h of x. Okay, now this is not f times x. This is saying the function f, when your input is x, equals. So I could say equals 2x plus 7. Or g of x equals 10 times 2 to the x. Remember those? This function right here is identical to this function. This function right here is identical to this function right here. Notice, all I did was replace the y with this little special notation. It's kind of like you go to Britain and you hear them talk, their dialect's a little different. You can understand most of it, but instead of using y, they change it to this.
To it like the F?
F of x.
F of X.
And I'll write that down in a second, how you read this. Yes?
So it's like in Python how you do functions, right?
Yes, it is.
So I'm going to just describe this. In the coding language Python, you would define a function by saying this line of code is equal as a function to this. So whenever I put this in, it runs this line of code.
Yes.
So that's the exact same thing with this, where f of x stands in for 2x plus 7.
Basically, they're the same thing, yes.
So it's like turning the big word into like just a small
Yes.
word.
Yes. So with this, what's going to show you, and remember the y is the range, the output is the range. We'll talk about that some more. The input is the domain. It's what's going into the function. We'll talk about that some more in a bit. Let's just look at the function. Does everybody have this down? I want to make sure you
What
all
is
understand.
hx?
H of x right now, I don't have a third function. Okay, I'll give you one. This is one we haven't worked on, but we were going to work on is quadratics. Okay, that's h of x right now. Okay, yes.
Isn't that gonna have two solutions then?
It does, no, that won't have. The range would be the opposite of that has two solutions. Because when I put x in, I only get one answer. But if I solve for x, I'll get two answers. And so that's going backwards. It doesn't have an inverse function. That's where we'll look at that. Okay. Okay, so let's look now at how to read this terminology, this notation that I just gave you. Okay. So f of x equals 2x plus 7. This stands for function f. So it's kind of like we named the function. We gave the function the name f. It is not a variable. It is just standing for the name of the function. We're talking about the function of f. Okay? This is talking about what is the input. This is the input. Well, x is going to be our input in this function. If I put a number in there, it means I'm actually going to put that number into the function. Okay? And this, we call this, it's equal to the rule. In other words, the rule is what do I do to that value of x to get my answer? So let's just do it like this. F of 4, that says input 4. Okay, we are going to put 4 in. What are we going to do with 4? Our rule says we're going to multiply it by 2.
2 times
And then
4.
we're going to add 7. So this rule says multiply by 2, then add 7. That's what the rule basically says. Okay? So when I input 4, what I get is 2 times 4, and then I add 7. So I get 8 plus 7, which equals 15. This is called the output. Because when I put 4 in, so notice I put the 4 in. So when I put 4 in, I get 15 out. Input, output. This is what we do to the number. We put the number in, it multiplies it by 2 and adds 7, which in coding, you do that all the time because you want to do things to the number. Okay? And so that's basically the same thing. What goes in is 4, when it comes out is 15. Because I put it into this rule, which multiplied by 2. So it's what we've already been doing. What we really get now, instead of x and y, we get f, x, and f of x. Do you notice that y and f of x are really the same thing?
No way.
Y is the same as f of x. Okay, they're the same thing. So if you don't like this notation, if you don't like the
I love the
notation,
notation.
that's fine. You can change it back into y equals 2x plus 7, and f of x equals 2x plus 7. I don't care. They mean the same thing. Those mean the same thing. Because one is just in a different notation than the other one. One is like you're speaking from Australia versus the United States. Australia uses different words than the United States for some things.
Like thong for flip flop.
Actually, they used to call that a flip-flop when I was young.
Really?
You used the word thong. I remember when my children were younger and I said, get your thong. And they went, Mom! What? Oh, shoot, that name, the name or the meaning of that word changed. It was a flip-flop back in my day. When you talked about thongs, they were the flip-flops that you put on your feet. Okay, it's changed. So we do have things that change too. Okay, this stays pretty consistent between two dialects. Okay, it's not changing right now. Y is the same of f of x. It's as if you're using a synonym for it. Okay, they are the same. Okay, so that's the notation itself. If I give you a problem like this, and I say f of x equals 10 times 2 to the x, and I say find f of 3, what would you do to get that answer? Yes.
10 times 2 to the power of 3.
Perfect. So it's 10 times 2 to the power of 3, because this says input 3 is the x. Okay, so I'm going to do that. I'm going to get 10 times 8, which is 80. There is my output. This is my input. Input, output. Okay, so that's the same thing. If you don't like working with that, then just go back to y equals 10 times 2 to the x. And you're basically saying when x is equal to 3, find out what y is and plug it in and see what you're getting. Or make a chart like this. It's saying x is 3, find out what y is. Okay, it's still going to be 80. So that's the thing that you have to look at. Okay. Now, domain and range. When you are looking at functions, okay, oh, we have actually looked at one other function, but we don't spend a lot of time on it. I just remembered. It's the absolute value function. So if I have y equals the absolute value of x minus 3 plus 4, that is a function. If I put in values of x, I will only get one y. This is how you look at it to see if it's only going to give you one y. Okay. So if I put a 1 in, I get 1 minus 3. What is that?
-2.
-2. And the absolute value of -2 is what? Mason, what's the absolute value of -2?
2.
2. 2 plus 4 is going to be 6. Notice I get one answer. Doesn't matter what I put in for x, I will always get one answer. That is true for any function. Okay. So somebody may say, well, what's a function where you don't, or what's an equation where you don't get just one number? Okay.
Isn't that just graph?
Well, we could graph them, but I'm going to give you one that you probably, sure. A circle equation, okay, is equal to y equals the square root of x squared minus the radius squared. So I'm going to say, and these are things we really haven't done, but we'll take this as 25. Okay, I want to find, so this is f of x equals the square root of, oops, we're doing let's do f of 3. No, sorry, I do it differently. F of 9, okay? So I'm going to put 9 squared minus 25 in there. Okay, 9 squared is going to be 81 minus 25. The square root of this, which is 56, is that right? Did I do it right? Square root of 56? 56. If I put that in the calculator, I will actually get one answer, but really, square roots have both a positive answer and a negative answer. So x would equal the positive square root of 56 and the negative square root of 56, because if I square this, it would be the square root of 56. If I square this, it will be negative, or it would be positive. So that is when we have something like this, and I'll show you why it's different. What does a circle look like? Well, depending on where it is, okay, here's my circle. If I look at my x values, if I go down, do you notice there's a value for that x here? And there's a y value for that x down here. So it has two different answers. So it's not a function, not a function.
Same thing with a rectangle.
Yes, any rectangles, any function. So one of the ones is this. This is the sideways quadratic. Remember our quadratic I showed you? This is actually a sideways quadratic. We can't do sideways quadratics because if you notice, for each x, I have two different values on the function. Okay, this is called the vertical line test. If you look at an x and there's two values for y for that x, it is not a function. Okay, these are not functions right here, because if I put that, if I look at x, a value for x, I have a y up here and a y down here. Two different y's, two different outputs. So those don't work. That's the difference between things that are functions versus not functions. Okay, you can only have one value. Now, absolute value, if you look at it, that one's a little bit different. I will put it back. It's 3 and 4. 3, 1, 2, 3, 4. This one will look like this. Notice, no matter what x I pick, if I put in x, I only get one value for y. So it is a function, because remember, you only get one output for every input. The way you can check that on a graph is just check. Here's x. How many points do I have that goes with that x? If there's more than 1 point, it's not a function. So that's why some things like that are not functions. Okay, so domains and ranges. Domains and ranges are easiest to see on graphs. Okay, so let's define what a domain is. Hi, Miss B.
Hi.
What are you looking for?
Rulers.
Oh, they're in there somewhere. Hopefully, I found them in your science room a few times.
Okay.
Actually, okay. So a function is when it's one output for every input. A relation is like the circle or this size graph, because it is a relationship between x and y, but it's not one specific. So when we're looking at domains of a function, and that's what we really look at, but sometimes they'll ask, what's the domain of this relation? Okay. Remember, domain is the x values. Remember, I told you domain is the x values or the input input values of the function. Really what you ask yourself is, what numbers can I input and get an answer? So when you are looking at a graph, and I have a straight line, I don't care what the straight line is there any value of x, and this is how I look at it, is there any value of x I cannot put into a linear function and get an answer? If I put any value for x, if I put -7 in a linear function, can I get an answer?
Yes.
Yeah.
Yes. If I put 3 8s in there, will I get an answer? You don't like them, but you can get an answer, okay? If I put 7,000 in there, will I still get an answer?
Yes.
Yes. So what values can I put in, or what numbers I can put in? I can put all real numbers in it.
So
Okay.
what numbers can't you put in there?
In there, there are imaginary numbers. We'll get onto that later, but right now, so a linear function, its domain is going to be all real numbers, because it doesn't matter what number I choose, I can put it in and I will get an answer, okay? So that's its domain, this is its domain. Now when I do that, this is a little harder. What kind of answers do I get out? Can we say, and the way I look at this, so the range, that's the domain, here's the range of the function, are the values, the y values that I get out. And when I look at this, I say, what values do I not get? Okay, and this will become more evident when we do a nonlinear function. Okay, so what kind of numbers do I get? Is there any limit to these numbers? So looking at this, if you think about the y's, is there any number I can't get as an output? It would be all real numbers too. So the relate, because everything I can get out, there's no limitations, so that's its range. Okay. So that's just saying, that's what domain is. What numbers can I put in it that I'll get an answer? What numbers will I get out? That's my range.
Which is y.
Which is basically y. Yes, it is the output or y. Okay, it's the output or the y. Okay. So let's look now at an exponential equation, and I'm going to just tell you that it goes down like this. Okay. So we've talked about it on exponential. We are doing models. Models don't normally go back here into the fractional parts. Okay.
But it's always 0.
Well, let's just look. So our domain, in other words, for y equals abx, what kind of values can I put in for x? Can I put 5 in for x? Can I put -5 in for x? Yeah, actually you can. We haven't talked about negatives yet. We are going to get to those, but you actually can.
Oh, so
It's
would
not
it
negative
add
years. It's actually going backwards
in
in
time?
time if you're doing time.
So
Now, there are things that we model with this that are not always based on time. Yes,
So for my polio one, for example.
yes.
Would it add like more cases to the,
If it's a decrease, yes.
yeah, so if I
Yes.
were to use a
Well,
negative
actually, you
number
don't
there-
have negative numbers in oh, no, you do. Yes, you do. Sorry. Yes, it would add, because you have a decrease function. So look at this. This is your decrease function. It starts up here and it comes down like this. Well, no. It's higher than that usually, okay? But it does come down. It starts over here and like say it comes, that's a really bad drawing. I can't draw it very well. But yes, it would add more up there, okay? So it would add to it if you go negative.
Okay.
So what happens is those are negative. We don't usually use negative years, but you can use years prior to see if it predicted for the past also. So if you use negative years, like 1 year since this value I got, then it would be -1. And a -1 is an exponent you can put in your calculator and it will calculate it for you. We will look at that later. In fact, Mr. Miller will be teaching you that, I believe. When he starts teaching, he's going to teach you how the -1s work, okay? So in here, what kind of values can I put in for x?
Any real number.
Any real number. So the domain for this is still any real number.
What's a fake number then? Can you show me? Can you just show me what
Square
fake?
root of a -1.
Thank you.
Okay.
The square root of -1 is a fake number.
domain,
Okay,
Domain expansion.
just stop.
the range. This one has a limited range. Look at your graph. What kind of values do I never get in this graph? Look at your y. What kind of values do I never get in my answer?
That
P.
Not a variable. Okay, look at your
fractions.
graph. This is y, correct? This is also y. Notice
you never
it
get a
never
negative.
goes down here. What do I never get? I never get negative numbers. And I technically never get 0. So here, my range is technically not 0, but anything a little bit greater than 0 can be
Infinitesimal or whatever.
never mind.
Infinitesimal.
Here, my range is y is going to be greater than 0. It's not going to equal 0, but it's going to be greater than 0. Or you could say all positive real numbers. But spell it right. I got positive something. So, in this, looking at the graph, you see that it never goes into the negative territory. So that means, and that's where I say, what values do I not get? I don't get negatives. So that means I have to just say it's all the positives that I get because I don't get negatives. Okay, so you can look at your graph. Okay, so let's look at one more just to get the domain and range off of it. My goodness, I don't know what they're doing out there.
Oh no.
That was Blake, I recognize. Blake's voice. His beautiful vocal cords.
Okay. X is here. Y is here. This is a absolute value.
Where's my break?
Never.
Okay, it will come. This is the last problem. I said this is the last problem before we go on break. Okay. So, what kind of values can I put in for X? Look at the graph.
4.
Any, I can put any in, okay? I can put any real numbers in, so that's my domain. Okay? Now, look at why. What can't I get or what don't I get? And then switch it around, that's your range, yes.
Anything less than 4.
Anything less than 4 is what I don't get. So, it's any number equal to or larger, because it can be 4. Okay? So, a way of writing that is x, and not x, it's y, sorry. Y is greater than or equal to 4. You can write it that way also. Okay? I don't care if you put it in words or you put it in symbols. I just want you to describe what the domains and the ranges are in this. Okay? So that's basically what we're going to do. We'll come back and do some up on the boards. So go ahead and take a break.
Are there any yardsticks in this
I have
building?
not found any. I have looked and looked and looked for those also.
I mean,
There are things that we do not have that we should.
We should.
Believe me, I go, what do we have?
Oh, I
can't
have
find
no
the
clue.
measuring tapes. I
They're
found them
either in
somewhere.
there or
Well,
in
I
there.
know, but sometimes I go to look for them. It's like,
Oh, I
this
know.
This is killer.
I know, it is.
And we don't have yardsticks because I wanted to measure things before and go, oh crap.
Yeah,
And I only have 2 at home, so it's not like I'm gonna have it for the whole class.
yeah, I think I only have 1 at home.
I'd have brought the one from my mom's, but it's warped, so I didn't think it would do much good
Yeah.
either, so.
I don't know. It'll be interesting. Oh, measuring tapes are back in here.
Okay, well now they're there. Don't know what they were before, but
They walk around.
yep, there they are.
You want them in here?
Oh, I don't care. I know I can look for them, it's just if I'm in a rush, then I
Well,
don't like
it's,
looking for them.
they're either there, or there.
I know. But in your room, there's many cupboards. This is easier to scan because
Yeah.
it's all in one spot.
Yeah.
That one there's many cupboards.
You don't know the yardsticks around here, do you?
I don't know.
There's not any in the corner.
No, it's not there.
So, shoot, that's okay, we'll try and.
I know we've had them.
We have a poll. Maybe they're down in grade school.
Right. Uh-huh. Trent would have a fit. No, she was looking for you to do the test. I went to Rick to do the thing and and then I was downstairs. I didn't realize what time it is. She made one up, and so I thought, oh, yeah, schedule a little bit. Let's see.
Yeah.
Oh, I forgot to shut it off again.